6, 10, 14, 17, 21, 25. BC students should already be working. BC students should already be working. Hey, AB friends, which is short for shut up, but it's rude to say shut up in class. So I just say shh. Good morning. You've made it. Okay, so tonight's homework is the same as what I gave you guys last night. It's assignment number 9. It's on page 63. Problems 3 through 10, 15, 19 through 26. Show of hands, how many of y'all have already started on it?
I already did it.
That makes me feel so good. Not sure why any of the BC friends raised their hands, but AB students, we have started. Yes. Now here's what I hope is happening. You are making really good choices about your notation. You're being really clear with your work. You're writing limit in all the right places. You're not doing stupid things like plugging in infinity. That doesn't exist. That's not a thing. Okay, I'm looking for this to be your A number 1 best assignment so far. And here's what I'm offering. I am offering that if that assignment really is superb, not only is it going to count in the gradebook, it's going to count in the gradebook even if it sucks. Okay, not only will it count in the gradebook, I will use that to replace a lower grade on any part of the summer assignment. Let me take one part. One part. If there's a part that's missing, however, no. Missing stays missing until it's not missing. Incomplete remains incomplete until it's no longer incomplete. But if you have a part that was like a 60 or a 70 and tomorrow's assignment is really good, that 60 or 70 automatically goes away and your grade goes up. This, can we all agree, is a good thing?
Yes, sir.
Excellent. Although I will drink your tears on a regular basis, as I have been told by Henry, I will also offer you ways to dig yourself out of the hole that you have found yourself in. Okay. Other things you need to know is that there is no lunch support today or any Wednesday ever because I need to be at the home office at 11 o'clock and I teach until 10:15 and my broomstick only goes so fast. Okay. There is a reassessment. Wizards need something. Reassessment is tomorrow during lunch. It is the first opportunity for a reassessment on that horrible quiz. I want the quiz grade to go away for the BC friends and the AB friends, but it only goes away if you've made all the corrections to the quiz. Everybody good? Yeah. All right, good. Everybody on your feet, please. Everybody on your feet. Everybody on your feet. It's time to switch the shame. Okay, time to switch the shame. For all the people that said Game of Thrones is your favorite show, maybe you're thinking about the queen walking through the city. It's like, shame! It's a thing, it's funny. Look it up. Winter is here. Sylvia's here, we can get started. Thank God. Okay, on the count of 3, the words are up here for those of you that don't remember to yesterday. Thank you, dear. Have a seat. Okay, here we go. On the count of 3. 1, 2, 3. In order for a function to be continuous, there can be no holes, no jumps, no breaks, and no vertical asymptotes. The whole is considered immovable discontinuity. Everybody good? Feeling good. All right. Now here's the thing. Here's what we're going to focus on today. Proving that a function is continuous at a point, it's just a matter of having really good, strong notation and everything being tight. Tight like my pants. Okay? So, shut up. So, there's 3 things that you need to show me. The first is that the function is defined at that point, right? So the point, show me the point. Andy, show me the point. Okay, the second thing that you have to show me. Second thing? I don't know, I stopped listening. The limit exists, not it, son, no. The limit exists. Daisy, show us the limit exists back there? Limit is x approaches c from the left and the right, better exists. So that's enough?
No.
The function's defined and the limit exists?
No.
No, why not, Jeanette? That's not it. But thanks for jumping in there, Paul. The limit, the answer from the limit has to be equal to how the function is defined. Is it possible that when you do the limits, there's a hole? And the hole's down here? And the function is defined up here? Is it possible that this could happen on a graph?
Yes.
Would this be a continuous graph?
No.
No. That's why you need the point to match the value of the limit. So on the count of 3, here we go from the top. 1, 2, 3.
In order for a function to be continuous at a point,
the function must satisfy 3 conditions. Number 1.
f of c is defined.
Number 2.
Limit of x
Exists. Number 3.
limit of x of x to c equals f of c.
If the function fails even one of these conditions, we're discontinuous. Everybody good?
Yes.
Excellent. Time for a little assessment. Alrighty, here we go. Yes, please. You have permission, Christopher, to sit in your new seat. Okay, Chris. But you know what? If I call you Bob, you're going to answer anyway. All right. So on page 28, Thank you, Karina, for making me a better calculus teacher and better YouTube celebrity. Okay. On page 28, there is a question right over here that I want you to do completely on your own. No help from anybody at all. If you want to use your notes from yesterday, feel free. If you want to look at the hints at the top of the page, feel free. This is just your opportunity to see how much you actually know. I hope it's a lot. 4, 7, 11, 15, 19, 23, 27. That's all the friends. Owie.
Because as you approach from the left, there is no graph.
It's a domain restriction. Unbounded behavior. Thank you.
Bless you.
I'll get it up a little this time for multiple. Use those notes. This is what I hope you're doing at night when you're working on my homework. Just if you're done, keep going. I don't want to slow you down. I like it. I don't love it. Now, to find f of c, that means like what is the value of the function at? In this case, 3. It's not a. This is not a question about limits. You're saying what is the value of the function at 3? So if I gave you this function, okay, what's the value of 3? You would figure it out by looking over here. Domain in which you use it. 3. Top. Looking at the example from yesterday is always a good idea. stuff happening here. This is really good. No, this is really good. It is actually one of the best I've seen so far. But Maryland's like, it's the second best I've seen so far. Sorry, he's dropped in the rankings. I have not seen the perfect paper yet.
Oh, I know. It's a
Set my light. Okay, can I borrow yours? No, wait. All right, friends, let's pull it together. Here's what I'm seeing on a lot of papers. I'm seeing f of 3 is the square root of 3 plus 1, which is 2. I'm seeing the limit, hold on, as x approaches 3 of g of x is the square root of 3 plus 1 is 2. I'm seeing the limit as x approaches 3 from the right of g of t is equal to 5 minus 3, which is 2. There are at least 2 mistakes here. 3. I want to get some hands. I am wicked picky about notation. The College Board is wicked picky. Henry, one thing.
Your x's are t's.
Okay, I need to be careful. Look at the function. What's the variable here?
T.
T, not x. You cannot change the variables. Do not change the variables. Ever, ever, ever. So, Henry, what do I have to fix?
All x you have x and t's.
Okay, so it's not limit as x approaches 3, it's the limit as t approaches 3. It's not the limit as x approaches 3 from the right, it's t. Great, I'm done? Everything's perfect?
No.
Karina, what else?
The G of 3.
G of, wait, but f of 3, right? The notes say f of c.
No.
This is the wrong function name. G of 3. You have to use the right function name, you have to use the right variables. Is this coming through loud and clear for all the friends?
Yes, sir.
I am wicked picky on this. The College Board is wicked picky, Chris. So are we good? Does the function exist at the point? Yes. G of 3 is equal to 2. Check. Limit as t approaches 3 from the left of g of x.
Oh.
Still don't like this? Jose, what's wrong?
It's G of t.
G of t. Now, because I'm approaching 3 from the left, I'm going to use the top piece, right? Numbers smaller than 3. And so I'm just going to plug in 3. 3 plus 1 is 4. Square root of 4 is 2. Check. Limit as t approaches 3 from the right. Bigger than 3, we use the bottom piece. We plug in, we get 2. Check. We're good? We're done? We're happy?
No. Yes. No.
No.
You have to
explain.
What's the third step? Are they all equal?
Yes.
Yeah.
G of 3, the limit from the left and the limit from the right, they're all equal. You could say this, since G of 3 is equal to the limit as t approaches 3 of g of t, like I've done that, I showed that they're equal. What's the conclusion?
They're continuous.
As c equals 3.
Therefore, g of t is continuous
At t equals 3.
at t equals 3. I heard somebody say at x, and they were like, oh, no, not x. If the independent variable is t, stick with that independent variable. The function name is g, stick with that. Okay? And you have to make sure you're telling me where the function is continuous. Otherwise, what you're saying is the function is continuous everywhere. Everybody okay? All right, I want to loop back around, though, and ask the question, is this function continuous everywhere?
No.
You don't.
You don't know. Some people just said no. Look at the pieces. Look at the different pieces. Square root of t plus 1. Is that continuous?
Yes.
Right? If I graphed that, that piece is continuous. How about 5 minus t? 5 minus x. That's a line. Is that continuous? that's also continuous. So I have a continuous function, a continuous function. Oh, and where they meet, it's continuous. Adrian, what do we got?
What do you mean, what do we got?
We've got a continuous piece over here, a continuous piece over here, and they snap together to be continuous at 3. So what can we say?
That, it's continuous.
I'm sorry, what?
It's continuous.
No, see, I lost it. I stopped listening when I get the word again.
G of t.
G of t is continuous where? Everywhere. Everywhere. We're good? Go for it. G of t is continuous everywhere.
Like the would like 0 less than, would that stuff ever make it not continuous?
It is possible, and as we go deeper, we're going to look at some other ones where maybe it won't be continuous everywhere. That's good. Yes, ma'am.
So since the whole function is continuous,
Yep.
if we don't put it's continuous at t equals 3, would it become
Well, Andy, the work that we did here was to prove that the function is continuous at that one point. If you want to go stronger, you're going to have to talk about the different pieces, how they snap together. You'd have to write more. Henry.
So wait, so how come when the one at the bottom has 3 less than but not equal to, it is still continuous?
Well, that's okay, because I didn't, as long as 3 is defined for one of the two pieces, we're good.
Oh,
Yeah. Yvel.
We call them pieces when we're trying to say everything's continuous. Like we say both pieces are continuous, meaning the function is continuous.
Well, both pieces of the function, right? Because we would call this a piecewise function. So this first piece is continuous, the second piece is continuous, and when I snap them together, they're continuous at that point. I think we're good? All right, good. All right, so time for a challenge. Now, some of you are like, no, we just had it, sir. No, we didn't. No, we didn't. Okay, here's the challenge, and I want you to take a minute, read over this, talk to somebody near you, come up with some ideas, see what you can do.
So you don't put the second one at the bottom, you can just plug it.
Say Perez.
So it's 3 minus 4, that's 12. This
Say you got
No, you can't plug it.
at the bottom, yeah.
Jeanette, honey, here you go.
Oh, you're wrong. Oh my god. But this one is 90. You can still use it.
Yeah, because this one was.
Well, guess what? 16 minus
Okay,
16.
page 26.
There's
No,
no
I
yeah.
wanted to say how you did it.
What about this?
26. Continuous at 0.
So we just continue to but just for the top one here. It's because remember if this ones don't match, it will be discontinuous already.
It's because X has a
Whole.
I sold it and then
Is that HBK?
Yes. Yes. That is not a mistake. All right, so I had a chance to walk around. You can tell I'm a little sweaty. And find a value of k such that f of x is continuous at x equals 4. And here's what I've seen so far. A lot of folks are like, well, continuity at 4, function name is f at 4. I'm going to find the limit as x approaches 4 from the left. I'm going to find the limit as x approaches 4 from the right. I saw a lot of people that wrote that down. It's a good start. And here's where I start to see some mistakes. What's f of 4?
3K plus 2.
I've seen 0, I've heard undefined, and I've seen 14. F of 4 means that the x value is 4. If x is equal to 4, I'm in the second piece. What's the second piece equal to? 3k plus 2. We don't know what K is. K right now is a mystery. Your job in this problem is to figure out what is the just right value for K so that everything's going to be continuous. So now we go to find limit as x approaches 4. And some of you are automatically going for 2 different limits here because you're like piecewise function, that's what we do. But check it out. Limit as x approaches 4 from the left. Which piece do I use?
You don't.
Top one.
I'm approaching 4, which means examples of approaching 4?
3.9.
3.9. I heard 3.99 from the pretty lady in maroon over here. First one or second one?
Top one.
Top one, because the numbers I'm using are approaching 4. They're not 4. So what I'm really looking for here, rather than f of x, I'm going to say 16 minus x squared over x minus 4. What if I was going to find the limit as x approaches 4 from the right? Same. So there's no need in this case to break it up into 2. You just need 1. So I'm not going to do limit from the left and limit from the right because it's the same function in both ways. Now, let's just wrap this one up. I need to find the limit as x approaches 4. Some of you may be having a flashback to the quiz that we had on Monday. This was almost exactly the first problem on the quiz. What can we do to evaluate this limit? What do we do? What do we do? Marilyn. Even before you do that, even before you factor, Daisy. Try plugging in 4 first. And what happens? 0 over 0 for a limit is the indeterminate form. Indeterminate form. So if we've got the indeterminate form, I need to do some work. And this is what I heard somebody already tell me what to do. Jeanette, do you have a question or a thought? Yep.
If we factored it out, will we still get 0 over 0?
Okay, so what I hear you say is, can I factor this out and what happens? On the quiz, I saw a lot of folks who tried factoring and the factoring went badly. Difference of squares, 4 squared minus x squared. The correct way to factor is 4 minus x and 4 plus x, with x minus 4 in the denominator. That's the correct factoring. People then wanted to cancel. I saw a lot of folks canceling x minus 4. Stay with me for a second. I want to clarify this. X minus 4 and 4 minus x. A lot of people canceling these. They're not the same. They are related to each other. They are not the same. They are opposites. X minus 4. Imagine for a second, 7 minus 4. Everyone's going to tell me? 3. 4 minus 7.
Negative 3.
Negative 3. Negative 3 divided by positive 3?
0. Negative 1.
On video too? Negative 3 divided by positive 3 is?
Negative 1.
Negative 1. They will reduce, but they don't cancel. They reduce, and what you're left with is a negative 1. Now you take the limit as x approaches 4, and you get negative 1 times 4 plus 4, which is negative 8. Henry.
What did you just do? Magic.
Are you okay with the factoring?
Yeah.
The 4 minus x and the x minus 4, these are opposites.
Oh, it's like you put any number.
Right. 4 minus 10 is negative 6. 10 minus 4 is positive 6. They're going to divide out and get negative 1. Okay. Go for it. You write the limit until you plug in. When you do the direct substitution, that's when you stop. Jeanette.
Why were you able to plug in 4 if one of the rows said that it couldn't equal 4?
Oh my God, Jeanette, that is the best question. Can you say that one more time?
Why did you plug in 4 if one of the rows said you couldn't plug in 4?
Why did I plug in 4?
Because
If the piecewise function is defined to say not 4, we're not actually truly plugging in 4. I think this is the part that can feel like magic and is weird in the beginning. you're not actually plugging in 4. You're plugging in something that is close to 4. As close to 4 as you can get to 4 without actually being 4.
Why didn't we just put 3.9 then?
And some of you tried that and then you get yourself all messed up over here. The idea is with limits, you are so close to 4, let's just see what happens if we were to evaluate it 4. And then that's when we're getting the -8. Now I just want to wrap this up so you guys can practice a little bit. We're not done. Why are we not done? You have to find K. What do we know so far? We know from the first step that f of 4 is 3k plus 2. We know from the second step that the limit does exist, and the limit is equal to -8. I need the just right value for K. Right, what I need is for f of 4 to be equal to the limit as x approaches 4. I need this to be true. Well, f of 4 we said is 3k plus 2. The limit is -8. We know what we're going to do here?
Yes.
Okay, so 3k is, what is that, -10? K is -10/3. That is all the work I would need to see. Beautifully organized so that you get this under control. Okay, so here's what I want to offer. We got about 5 minutes left, a little less than I wanted, but it's okay. If you are feeling like, man, I just need some practice with this notation stuff, focus on problems 1 or 2. This is page 29. If you want more of a challenge, focus on problems 3 and 4. The goal is that you can get 2 of these done in the next 5 minutes. Work with a partner if you need to. I'm going to go check in with the BC kids. Apparently there's a nickel on the floor. It's very distracting for them. That's okay. Monday and Tuesday as well. Okay? Okay. Either working on 1 and 2 or working on 3 and 4. Anybody want some extra paper? Okay. Extra paper. Diego. Here you go. Extra paper. Extra paper. That's you, Andy.
Rebecca, Daisy, Karina.
Y'all might want to move your desk back. BC students, I hope we're on track to videos. Yes. We're watching. Wait. Education. That's you. Education. Mister. Mario. He said, "Madam's what you
Bless you.
Be careful with your variable and your function names. How are we doing here, friends?
how are you supposed to plug in the
Not as I approach zero, f is continuous.
Yeah, it's no, no one.
And then when I do it,
Well, like, the sine equals, when sine equals 0,
it always has an equation of 1. That's true.
So the tangent is sine of 0 is sine of 0 is 1.
Oh, 0 divided by 1 is sine equals 1.
Oh, okay. Okay, I like it, I don't like to do this, right? Here's what I don't like. Okay, over here, you're saying limit as x approaches 0. I'm going to read this in For now, it looks like we're in the
Alrighty, friends. Okay, so before everybody takes off, we know about the assignment that's due tomorrow. Reassessment opportunity number 1 is tomorrow during lunch. Not here today during lunch. Sorry about that. Had a great session. See you tomorrow. Get the homework done. Andy, it is so nice to have you up here and not like shoving you out of my way. My next task with you is to keep your shirt tucked in. That's tomorrow's goal. You cannot bring shame to this table. Hi, Jackie.